In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. Energy, the ultimate galactic transformer. Forever morphing from one form to another. It powers our planet and everything else in the universe. But what exactly is it? Where did it all come from? And how do we get more?
Energy can be neither created nor destroyed. It can only be transformed from one type to another.
This transformation sometimes goes to the extremes in objects like black holes. Could a future civilization harness that power?
What a neat way to get rid of your garbage and solve your energy crisis all at the same time.
And what if our universe's energy was transferred to another place in time?
What if a passageway opens up to a parallel universe and bleeds off some of that energy? Life wouldn't be able to withstand that.
This is the story of energy, from the Big Bang to your own backyard. Charge up your engines as we follow the trail of extreme energy in the universe. Energy is a cosmic chameleon. It drives our universe by constantly changing form. It powers acceleration, expansion, and apocalyptic impacts.
Everything in our universe is energy. Your energy, trees are energy, the dirt is energy, and even the empty space between the stars is energy.
But where does all this ever-changing energy come from?
All of the energy we see around us every day actually comes from the very beginning of the universe, billions of years ago. When you see a car accident on the highway, that's a very energetic event. Cars get mangled, there's a big noise. But where did the energy come from? Well, the energy comes from the energy of motion of the two cars before they crash.
But where do the cars get their energy? From gas, a fossil fuel that gets its energy from plant life that was living millions of years ago. Plant life that got its energy from the sun, which gets its energy from nuclear reactions inside the core.
Those nuclear reactions get their energy from the particles that were created at the time of the Big Bang.
All the many forms of energy we see around us come from the Big Bang. The beginning of the universe.
The origin of all the matter and energy in the universe is really the Big Bang, the creation of the universe itself. Now we think that in fact, the Big Bang was the sudden expansion of a very small amount of space into a very large space, driven by a weird kind of an energy.
We're not sure what type of energy kick-started the Big Bang, but whatever it was, in one brief instant, it produced all the energy in our universe, past, present, and future. This is one of the most important and surprising aspects of energy. In black holes, exploding stars, or even power plants on Earth, it can be neither created nor destroyed. It can only be transformed from one type to another.
If the laws of physics in the universe never changed in the past and don't change in the future, then no energy can be created or destroyed. It can only be transformed.
Transformation is the key to how energy works. The universe is filled with many forms of energy, such as light, sound, thermal, and chemical. The most common among them is potential energy, the stored or pent-up energy of an object, and kinetic energy, the movement of an object. And all forms of energy are constantly converted into other forms of energy.
When you fire a gun at a target, you might think that once the bullet hits the target that energy is gone. But it's not actually gone. It's actually just been transformed into another type of energy. The chemical potential energy in the gunpowder has been converted into the kinetic energy of the bullet, sound waves, heat, and whatever energy gets transferred into the target, maybe causing it to move or explode.
Even the human body is a fine-tuned energy-transforming machine.
A good way to think about how we transform energy is eating. Humans eat a certain amount of calories every day, and then whatever physical activity they do that and burn off that certain amount of calories. And you have to continue to eat because you continue to be active and burn off calories.
Incredibly, Albert Einstein realized that energy and matter are really the same thing, and one can be converted into the other. That's the meaning of his famous equation, E equals mc squared.
Einstein came up with a way to explain that everything in this universe is energy. Matter is energy. If you weigh, say, 100 kilograms, that's your mass. And if you take that and you multiply that by the speed of light and then multiply that by the speed of light, then you get the amount of energy that exists within your body. Actually, about 1,000 times more energy is in your body than there was in the largest nuclear weapon detonated by mankind.
Objects may have the same amount of energy, but that doesn't mean they have the same amount of power. The key ingredient is how quickly the energy is released.
Power is equal to energy per unit time. So even something with a really small amount of mass, like say this cupcake, would have the equivalent energy of about 1,000,000 tons of TNT. We all know that cupcakes don't spontaneously explode and emit 1,000,000 tons of TNT. If I eat a cupcake, it only gives me about 200 calories of energy over several hours. Whereas if I have a stick of dynamite, that same amount of energy would be released in, say, 1,000,000th of a second. So the TNT has much more power, even though it has the same amount of energy.
If you have a pizza and you're going to eat that pizza, say you eat 1,000 calories worth of pizza, that might be a big meal, but your body has to convert the matter of that pizza into that 1,000 calories. And it's really not that efficient. Take, for example, the same mass in TNT or dynamite. When you light the fuse on that, you get way more energy.
All of the energy we use here on Earth to feed our bodies, power our electronic devices, and light our homes ultimately comes from outer space. Some of the most extreme transformers of energy are stars, including our sun.
At any given second, the sun is putting out about 10 to the 26 watts. That means a 1 with 26 zeros after it. That's like 400 billion nuclear weapons, all in 1 second. That's how much energy we're getting from the sun at any given second.
Stars, like our sun, produce many forms of energy. But it all began with gravity.
All gravity means is that we've observed that all matter falls towards all other matter. And it's interesting that you can use gravity to transform energy from one type to another. If I hold a rock up here, it has a certain potential energy. And then I let it go, gravity turns that potential energy to kinetic energy until it hits the ground.
Over 13 billion years ago, gravitational energy gathered up dust and gas to form the first stars. Once a star is formed through gravitational energy, it then produces nuclear energy.
Stars are powered by nuclear fusion. So this is when you take multiple hydrogen atoms and you smash them together to produce heavier elements like helium, or carbon and oxygen and nitrogen. When this fusion process happens, the enormous energy of what's called the strong nuclear force is liberated. And that is what lights up the star.
Nuclear fusion within stars, like our sun, then produces a form of energy called electromagnetic radiation. These are oscillating waves of photons, or particles of light. On Earth and in space, electromagnetic radiation consists of a spectrum of energy. On the low end are radio waves with low frequencies and very long wavelengths. On the high end of the electromagnetic spectrum are gamma rays with high frequencies and extremely short wavelengths.